Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
So friends, in the previous lecture we have studied about the rules of the IUPAC Nomenclature of Alkene, and now we are going to apply on the few structural formula of alkenes. So let us talk about that. So now we are going to give the IUPAC nomenclature to the alkenes, that is the structural formula of alkenes that are being provided to us, and let us see that what is the IUPAC nomenclature and how can we give the IUPAC nomenclature to that particular molecule. So now let us talk about the first one that we have. So this is the first molecule that we have, and this is the one. It is very easy to understand that this is an alkene because of the carbon-carbon double. So no need to set the longest chain because it doesn't consist of any branching. So for that extent also, so suppose if we, even though if we have selected this as the longest chain, suppose in this one, it won't be that much difference. But let us give the numbering. So the numbering is the main concern, and that number will give the location of the carbon-carbon double bond. So in this case, suppose if I number it from, I can number it from either side because in this case no branching is being there, so as to give priority to the left hand side or the right hand side through which the double bond is very near, or through which the branching is very near. So we could number it from anywhere, but let us see whether the double bond is near to which end. So suppose if I number it from here, this one would be the carbon number 1, this one would be the carbon number 2, third, and this one would be the 4th. So in this case, suppose I would see that the carbon number 2 is in the one where if I receive a carbon-carbon double bond. So that is the thing that if I move from left to right. So what if I number it from this side, that's again carbon number 1, suppose this is carbon number 1, this is carbon number 2. Again what I am getting is, again I am getting the carbon number 2 from which the carbon double bond starts. And this is 3 and this is 4. So either side I could number it from any one of the sides. So let me give the number first, 1, 2, 3, 4. So total number of carbon, that is the parent chain in this case, basically consists of 4 carbon atoms. And this 4 carbon atom which consists of only one carbon-carbon double bond, making this to be called as basically butene. But this is not butene because we have not expressed the position or the locant of the carbon-carbon double bond. And in this case, as I could see, that the carbon-carbon double bond is present between the carbon number 2 and carbon number 3, making this to be named as but 2E. And this 2 represents from where the carbon-carbon double bond is started, or as because the thing is we are numbering from left to right, so that's the reason that is the carbon carbon double bond will start from carbon number 2 and it will end at carbon number 3. So that is what this number indicates. So therefore, the IUPAC nomenclature of this molecule is nothing but but 2E, a very simple one. So now let us start with the another one. So this is another molecule that we have, and we have to give the IUPAC nomenclature to this also. And the first rule is what we know is we have to select the longest chain. But suppose if I write this in this manner, this molecule in this manner, where I have to get a longest chain that consists of carbon atoms. So if I consider this to be the longest chain, so I could get the carbon number as 3. But is that valid? No, it is not valid. The reason behind that is, as I could see that there is presence of carbon-carbon double bond, and in spite of getting the carbon-carbon double bond over here, we can't ignore that. And if we ignore that, what is the thing that we could get is we could get carbon-carbon single bond, and which represents an alkane. So this is not an alkane, but actually this is an alkene. Because according to the definition of alkene also, we have got to know that there should be presence of carbon-carbon double bond in that hydrocarbon or in that kind of molecule. So therefore this is an alkene that we know. So the both are represented as alkene, but this is the wrong method to represent the longest chain. So therefore the correct method is we have to set the longest chain in such a manner that it should contain at least carbon-carbon double bond. So that's the reason this is the correct method of setting the longest chain, where we have found out that there are 3 carbon atoms here also, but it also includes carbon-carbon double bond. So therefore this is the correct method. So this job is been done, that is the finding of the longest chain. But the work is not done yet. We have to number it, and yes, we have to number it from which end. We can number it from here and this also, that is carbon number 1, 2, 3. but this won't be validate the rule of the IUPAC nomenclature that we have did for alkene. So we have to number it from that end where we could get the carbon-carbon double bond a less number. We can get a carbon-carbon bond that is the locate number would be less from that end. So therefore, if this is the one, if I consider as carbon number 1, 2, and 3. So now we could easily number it, and this is the number that we have got, and now we can easily give the nomenclature of this one. So, but before giving the nomenclature, we also know that at second position there is CH3 group is present. So now, because of the CH3 group is present on the second carbon atom, so therefore the name is we have to give the group name to be first, and after the and after at the last the parent name would be coming. So therefore, this is the group that has been added, that is CH3. So therefore, it has been added on the second carbon atom. So therefore, making it to be known as 2-methyl. And the total number of carbon in the straight chain is basically 3, calling that to be basically propane when it comes to an alkane. But this is not propane, this is propene. And moreover, we could see that the carbon-carbon double bond is starting from the carbon number 1 and it is ending at carbon number 2. So therefore, the name of this would be methyl 2-methyl prop 1-ene. So this is the IUPAC nomenclature of this molecule that we have. So this is the precaution that we have to take. So I hope you have understood this very clearly. So now let us move on to the third one. So this is the third molecule that we have, and we have to name this as the IUPAC nomenclature of alkene. So now we are going to try varieties of the structures, whereas we could give or we could see that where we could get confused, or we should prefer which of the sequence, that is from left side or right side, or in any manner, and in that terms also we can also be able to set the longest chain that will consist of the carbon-carbon double bond. So all kind of rules will observe in this nomenclature. So this is, let's talk about the third one. So this is the third one that we have, and the first thing that we have to do is the very common thing that we have did in alkane also, that is we have to set the longest chain of carbon atoms, and that should also be in continuous form. So in this case, I could easily predict that this one is the longest chain that I could observe, and now the main thing is numbering. So in the rules of IUPAC nomenclature, we have also studied about that we should number in that manner where the branching is very near, but that is only applicable to the carbon-carbon double bond if it has been equidistant from both the ends. So in this case, there is no chance of numbering from here. The reason where that is, if I number it from here, I could get the carbon-carbon double bond very nearer to this end, and that is the main priority rule. That is, we should always focus on the carbon-carbon double bond, and then let's see that. Then let's see for the branching one. So now this is the one that we will focus on, and I could see that this carbon-carbon double bond is very much nearer to this end. So making us to give the sequence of number from this end in itself. That is, this one will be the first carbon, second, third, and fourth. So now the naming it will be very much easy. So now at the third carbon atom, and again on the third carbon atom, I could see the methyl groups are being present over here. So therefore, we are going to name the methyl groups or the branching groups first, and then will come back to the parent chain. So in this thing, I could see that methyl groups are being present on the third carbon atom, and again there is 2 methyl groups that are being attached on the same third carbon atom. So therefore, we could name it as 3,3 dimethyl. So this is the work done for the groups or the branch that we will see in this straight chain or parent chain, and let us talk about the main parent chain itself. So the parent chain consists of 4 carbon atoms, and this 4 carbon atoms is, in terms of alkane, will be known as butane. But this is not butane. This is an alkene. So we'll name it as butane. But what about the number, or what about the locant of the carbon-carbon double bond? Yes, even that is the one that we should consider. We consider that the carbon-carbon double bond starts from carbon number 1. So therefore, the name of this would be but1-ene. So in this case, basically the number is also playing a very vital role. This one represents the carbon-carbon double bond starts from the carbon number 1. So suppose if this would have been 2, then the overall structure would also have been changed. So that is the thing that we should follow the IUPAC rules. Not a tough, but a very easy to learn the IUPAC nomenclature of alkene. So this is the one that we have made. So let us move on to the next one that we have. So this is the one that we have, and we have to give the nomenclature of this one. This will be very much easy for you, but the change is it doesn't consist of only one carbon-carbon double bond. It consists of two carbon-carbon double bonds. So the naming would be a bit different. Yes, we are now talking about the seventh, that is rule of IUPAC that we have mentioned in our lecture in the previous section. So let us select the longest chain. No need to select the longest chain because it is itself clear that this one will be the longest chain. And the main thing is numbering. The main thing is numbering now. So we could number it from this end also and even in this end. So we know that we should number from that end where we could get the carbon-carbon double bond nearer to that end. So therefore we will number it from here. So therefore this is the first carbon atom, second, third and fourth. Now the numbering is been done and the only thing that has been left is to name. But by naming this thing, it consists of 4 carbon atoms, and 4 carbon atoms in comparison to that is alkane. If you observe, then it would be basically butane. So this is not butane, this is butane. And moreover, we could see there is not only one carbon-carbon double bond, there are 2 carbon-carbon double bonds, making this to be called as butane. This A, it represents there is not only one, but there are multiple carbon-carbon double bond present in the molecule. So therefore, this buta that we have mentioned over here. And before writing the suffix E and E, that is E, we have to represent the number of the from which the carbon-carbon double bond originates, or from which we could see that the carbon-carbon double bond is present between 2 carbon atoms. So therefore, we could see that the carbon number 1 is the one where we could see that carbon-carbon double bond is present. And on carbon number 2 also we could see that carbon-carbon double bond is present between carbon number 2 and carbon number 3. So therefore the name of this would be buta 1, 2 di. This di is for the total number of carbon-carbon double bonds. It represents the total number of carbon-carbon double bonds. Di, and overall it is an alkene, making this to be called as buta 1, 2 di. A very simple one, and in this case we have also followed the 7th rule. So not a very big complex thing, but it was we have just started with a very simple one, and let us start with the another one, and let us see how can we name that. This one could be a bit difficult, or yet you have to make your mind to switch on that we have to name it from which end. So this is the one that we have, and we have to name it, and the more biggest thing is we have to select the longest chain, and that should also consist of carbon-carbon double bond over here. So selecting about the longest chain that we could name it, or we could arrange. So I could arrange in this manner also, that is 1, 2, 3, 4, 5, 6. 6 carbon atoms would be the longest chain, and we could see that carbon-carbon double bond is also present. So not only this one, we could also set as this one as the longest chain. So therefore again 1, 2, 3, 4, 5, 6. So just for a convenience, it is not necessary that we should always consider only straight chain in that manner. But the main thing is we have to select the chain in continuous form. So for a convenience, suppose if I am selecting this as the longest chain, let me tell you again that even this could be considered as the longest chain also. So let's come back to this one, and the work has been done. That is, we have selected the longest chain, and now we have to work on our mind that from where we should give the sequence. That is from left to right or right to left. So that is the main thing. Suppose if I give the sequence of numbering from left to right. So in this case, I can get a 1, 2, 3. So I am naming it numbering it over here. That is from third carbon double bond starts. 4, 5, 6. And what if I have numbered it from here? That is 1, 2, 3. Again, I am getting the number 3, 4, 5, 6. So in both the cases, I am getting an equidistant distance of the carbon-carbon double bond from both the ends. But we have to prefer which number? Anything that we have to prefer that is either from left or either from right. The reason of the word preference is because of the groups that are been attached to it. Yes, the groups that are been attached over here, that is basically an ethyl group and a methyl group. So that is the reason that we have mentioned the word preference, so from where we could prefer. So the main thing is alphabetical order. Yes, this is the one that we have studied in the IUPAC Nomenclature of Alkene also. And suppose in this case, suppose the branching is the one which is in also the equidistant from both the end. So we have to name, we have to number it from where or from which end, that is from left to right or right to left when the structure is in this form and we have selected the longest chain in this rectangular manner. So we'll number it from that end where we could receive the branching having an alphabetical order. So that is the reason that I am going to explain you about, because this is 2-methyl, that is CH3 CH2 group, that is ethyl group is present, so it starts with E, while the methyl group it starts with M. So making us to give the number sequence from left to right. Yes, this is what we have learned right now. That is 1, 2, 3, 4, 5, 6, and this is the number sequence. And the number I have got for ethyl, ethyl has got the number 3, while methyl has got the number 4. So this is the number that we are talking about. What about the writing? That is, how we'll write the IUPAC nomenclature. Means ethyl would come first or methyl would come first. That is the thing that I want to explain. It will be always alphabetical order. Regardless of the number that ethyl has, it might be 3, 4 or anything, but it should be in an alphabetical order. So in this case, fortunately, 3 is the lower number and ethyl is the one that it will get a preference and we will write ethyl first. But suppose what if in the case, suppose if this has got a fourth number and this has got a third number, again the ethyl would have been written first with the number of with the position of it, which is of the parent chain which has been attached to. So therefore, in this case, basically the position of the ethyl group is on the carbon number 3, making this to be named as 3-ethyl, then 4-methyl. So this is the group that we have did our work by representing the group that have been attached on the number of carbon, that is third carbon atom and the fourth carbon atom, that is the locate. And now let us move on to the main thing, that is the parent chain. So the parent chain consists of 6 carbon atoms, making this to be called as an hexane when it comes to an alkane. But this is not an alkane, this is an alkene. So therefore the name would be hexene. And we are missing something. Yes, we are missing the locate of the carbon-carbon double bond. Yes, the carbon-carbon double bond is present between the carbon number 3 and carbon number 4, making this to be named as hex 3. So this is the nomenclature of it. Now let us start with the another one. That is this one. So now the thing that is, we have to again give the IUPAC nomenclature, but how can we give this? Because this consists of a branching also. So the first thing that we are going to do is select the longest chain that consists of a carbon-carbon double bond in that manner. So suppose I've selected this as a carbon-carbon. Elongation that consists of a carbon-carbon double. But while numbering it, I could number it from this end also. The reason behind that is, as I will move from this number to this end to this end while numbering, so this is what I could get maximum branching. So at the second carbon, I could see more branching compared to that of this one. So if I number it from this end, that is, this is 1, this is 2, then the second has only 1 branching, while 3, 4 has basically 2 branching. So should I number it from here? No, I can't number it from here. The reason behind that is, this is not an alkane. This is an alkene because it consists of carbon-carbon double bond, and we have to only give the priority first to the carbon-carbon double bond and then to the branching. So that led us to make the number sequence we gave in this manner, that is 1, 2, 3, 4, 5. So this is how we have numbered it, and the thing that we have to do is, yes, we have to just detect that how much and which are the groups that are attached to this carbon atoms or the chain that we are, the side chain that we are talking about. So there is no another side chain. There are basically the groups that are being attached. That is the methyl group. One is over here, So there are three methyl groups. One is attached on the on the second carbon atom, and the next two are being attached on the fourth and fifth carbon atom. So therefore, making this to be called as, when it comes to the group, so the name of the group would be basically represented in this manner, that is 2, 4, 4, because the methyl groups are being present thrice, or we could say three times the methyl group is present in the overall chain or in the overall molecule, which has been attached to the parent chain. So therefore, the name of this would be 2, 4, 4 trimethyl. So the work is almost done, and what we have to do is we have to consider the parent chain, and the parent chain consists of 5 carbon atoms, and that 5 carbon atoms in terms of an alkane is pentane. This is not an alkane, this is an alkene, that is pentene. But the carbon-carbon double bond is present at a specific location, or we could say as a locant or number. So it is present between carbon number 2 and carbon number 3. So therefore, making us name this as 2, 4, 4 trimethyl, that is pent 2 E. So this is the name of the alkene that we have drawn. So it is very much simple to understand, and yes, that is the kind of variability or variation that we have studied, or kind of difference that we have studied in alkane and alkene. So that are the priorities that we have understood in this example. So this is the sixth one, and the name of this is basically, as you could see, pentene, that is pent 2E. So now let us move on with the next one, and let us try that also. So this is the one that we are going to try, and we have to give the IUPAC nomenclature to this one. So the first thing that we have to do is we have to set the longest chain, and clearly it indicates that this one with the longest chain, and that consists of carbon double bond. And while numbering it, so the numbering is the main challenge thing always. So that is the preference. We have to number it from which end. That is the main thing. So I can't number it from this end. The reason behind that is, suppose if I number it as 1, so at carbon number 2 I will get that is the carbon double bond. While if I number it from here, then I could get at the first end only, that is at the first place only I could get carbon double bond. So making us to give the number from this end. So therefore this would be basically 1, 2, 3, 4, 5, 6. And now I could easily name it, but before that let us express the positions of the substituents, or the position of the groups that have been attached to this parent chain. So that is a methyl group. 2 methyl groups are present at carbon number 3 and carbon number 5, making this to be named as, in terms of the methyl groups, that is, it would be written as 3, 5 dimethyl. And the total number of carbon in the straight chain or in the parent chain is basically 6, according to be that as hexane. But this is not an hexane, this is hexene. And the carbon-carbon double bond is not only once, it is basically twice, it is thrice. So, and they are present at carbon number 1, carbon number 3, carbon number 4. So the name of this would be basically, when it comes to hexane, and it comes to an alkene like hexene, but the name of this would be hexene, it would be something hexa. Yes, the reason behind that is it has not only one carbon-carbon double bond, it has 3 carbon-carbon double bond. So therefore the name of this would be hexa, and those carbon-carbon double bond are present at carbon number 1, carbon number 3, carbon number 4. And how many carbon-carbon double bond are present? 3 carbon-carbon double bond are present, so making this to be called as tri. So overall the name of this is basically 3, 5 dimethyl hexa 1, 3, 4 tri. And this 1, 3, 4 represents the position of the double bond, while this 3, 5, this number represents the position of the methyl group that is being attached. So therefore the two numbers are different. One represents the total number of, one represents the position of the double bond, while one represents the position of the substituents, or the position of the atoms or groups that have been attached to the parent chain. So that is what we have to make in a concern, that what does the number indicates. That is the reason IUPAC plays a very important role when nomenclating a particular alkane or alkene or whatever a hydrocarbon is. So this is an interesting one that we have taken. So let us move on to the last one, that is this one. A very easy one. I think no need to give you a guide on this thing, that is no guidance is required for this, that is we have to set the longest chain. So this is what we have did, and only the thing is the sequence of the number, that is from which end that we have to give. So in this case, let me give you an idea, that is suppose if I numberate from here 1, 2, 3, 4, 5, 6. So the carbon-carbon double bond starts from the end, that is from the carbon 2, then 3, then 4. So what if I number it from this end, that is 1, 2, 3, 4, 5, 6. So in this case, we see the carbon-carbon double bond starts at carbon number 2, carbon number 3, and carbon number 4. So if you notice, the both are the same. So no need to give a preference from left side to right side or right to left. The both are the same while giving the number. So the number, so the name of this would be basically, since it consists of 6 carbon atoms, in terms of an alkane it would be called as hexane, and in terms of an alkene it would be called as hexene. But it has not only one carbon-carbon double bond, it has 3 carbon-carbon double bond, making this to be called as hexa 2, 3, 4, because 3 carbon-carbon double bond are present, so therefore I would mention over here as tri, and overall it is an alkene, so making this to be known as tri. Very simple. So this is what we have learned about the IUPAC nomenclature of the structure that was being provided to us, and it was very easy task, and we have learned some interesting thing also in this case. So thank you friends for watching this video. I hope you understood this video very clearly and will share this with your friends, and yes, don't forget to subscribe. Thank you so much.